Hello everyone. Today I will explain homework 6. Okay, so first question. The diagram shows apparatus that can be used to make a magnet. Okay, which metal and which power supply are used to make a permanent magnet? Permanent magnet made of steel, and it must be connected to a DC current, direct current. Okay, in which pair are both material magnetic? Iron and steel is a magnetic material. Easy questions. All of these easy questions. Okay. A strong electromagnet is used to attract pins. What happened when the current halved? If the current halved, it become a weaker magnet. So some pins are attracted, but not as many. The number of pins attracted will be lower. Now, in two separate experiments, a magnet is brought near to an unmagnetized iron bar. Okay, this is iron bar only. This causes the bar to become magnetized. So as you see, if we have S here, this must be north. If we have north here, this must be S, because it's just iron bar, so it will be induced magnetism inside it. Okay, so now this is S, this will be N. So I have to choose N and N. Now, a small compass is placed close to a strong bar magnet, the same distance from each end, which diagram show the direction in which the compass needle point. As I said before, you have to draw the magnetic field, and as you know, the magnetic field from N to S, so C is correct. In a child's toy, metal fish are lifted out of a toy pond using a metal rod. The fish are magnetically attracted to the end of the rod. There is no magnetic force between the fish themselves. Okay, it means the fish is metal only, iron, for example. Okay, what are possible material from which the fish and the rod are made? Because the rod is a permanent magnet, so it must be made of steel, and fish will be soft iron because it's unmagnetized. So D is correct. What's wrong with the label diagram of a permanent magnet? Permanent magnet made of what? Made of steel. So iron disc is wrong. So this will be C. In which way are a bar magnet and an electromagnet similar? Bar magnet and electromagnet similar on what? They can both use two separate magnetic material and non-magnetic material. Easy question. Now we have iron and steel. A train of steel nails and a train of iron nails hang from a strong magnet. The trains are then carefully removed from the magnet. What happened to the trains? Both trains are full, wrong, because we have a steel, it will keep magnetism for a longer time. Both trains stay together, no, because iron will lose magnetism easily. Only the train of iron fall. This is correct. Okay. Two magnets X and Y are placed end to end on a bench. The diagram shows the magnetic field pattern between the poles of the magnets. So as you see, we have, this is the direction of magnetic field. It means X is N and Y is S. Okay, so now which row showed the direction of the force exerted on X and Y? Of course, X will be attracted to Y, so this is the force direction of X, and also Y attracted to X, so this is the force on Y. So on Y it will be this direction, and this is the correct answer. The resistance of a wire depends on length and cross-section area, and we said before directly with length and inversely with what? With cross-section area, so B is correct. The table described 4 different resistance wire. They are all made from the same metal. Which wire has the smallest resistance? Because with length directly and cross section inversely. So you want the smallest, you will choose the smallest length. Then if we increase cross section area, R will be less, I will choose the thickest, so it will be B. Also, you can use another way to solve this question. You can find every time R L over A, so L is 2 over 1 equal 2. 2 over 1.5 equal 2 over 1.5 equal 1.3. 3 over 1 equal 3. 3 over 1.5 equal 2. So this is the smallest one. So B is correct. We have two ways here. Okay? Two methods. The diagram shows 4 current voltage graphs. Which two graphs show the characteristic of ohmic conductor. Ohmic conductor must be straight line. Filament lamp, the curve toward V. So the curve toward V. So the answer is X and Y. A resistor of resistance R is connected to a battery. There is a current I. Power P is dissipated by the resistor. Which expression correct? E equal IVT. This is equation, so it's correct. Yeah, you have to memorize it. A circuit contains a fixed resistor. The potential difference across the resistor is 24 and the current is 2.3. How much energy transferred in 17 minutes? So first you have to convert the time 17 multiply 60. Okay, then you have to, because now we convert it to second, energy equal V multiply I multiply time, it will be equal 56300 joule. You can choose expression kilojoule. So this is correct. 4 wires are made of the same metal. Which wire has the greatest resistance? Greatest resistance, resistance equal L over A. So greatest resistance, longest and thinner. So I will choose longest and thinner. This is the diameter. Diameter also same expression for A, cross section area, because it's as a pi diameter squared over 4. We take also L over diameter squared. So as diameter decrease, resistance will increase. The graph shows the current voltage characteristic of for a conductor. Where on the graph Ohm's law applied? طبعا in straight line. So it will be Q. Now the diagram shows a circuit of 6 identical lamps connected to battery. Which lamp brightest means it has the highest current. Highest current. So as you see, B is the brightest because it has the highest current. Okay, but in R and the Q the current will be split also. It will be split here. So the brightest is B. The diagram shows a battery connected to a potential divider and 2 lamps P and Q. As you see here, we have, this is a parallel connection. Okay, but here inside this branch we have a series connection, uses this pointer or this slider. Okay, now Q is connected in parallel with only X. Pay attention. Okay, the slider on the potential divider is moved from X to end Y. So the slider moving in this way. So it means this voltage increase and also voltage of lamp increase and the voltage of Y decrease. But what about voltage of P? Same voltage. So now brightest of B unchanged because the B has its own voltage. It doesn't change. Brightness of Q increase because voltage increase. So pay attention again. This is part X connected in parallel with lamp Q. As you move the slider right, the resistance increase. So and voltage equal IR. So as resistance increase, voltage of X increase. So Voltage of Q is increased also because it's in parallel connection with X, so the answer will be C. Two resistors R1 and R2 are connected in series in circuit as shown. The circuit in a series is I/O. Another resistor R3 is then connected in parallel to R2 and as shown. How do the current I1 must be greater than I/O because we have now a lower total resistance. R total decrease because we have parallel connection here. It will make this resistance lower than this resistance. Okay, so I1 will be smaller than I2, but of course I2 will be lower than I/O because we have a splitting current here. So I will choose D. This is why I choose D. Now we have a magnet, okay, as N pole moves toward X. If the magnet moves toward X, X will be N. If the pole move away from X, X will be S. So this is the correct answer. The diagram showed a short-circuited copper coil swinging between about an axis at right angle to a strong magnetic field. The motion induced a current. So what is the correct answer? Lenz's law. Induced the current to produce a force to oppose the change in it. Now in this diagram we have, this is the direction of magnetic field. It means here we have N, we have S. Okay, now he said the magnitude of a potential difference across increased. It means it becomes stronger magnet, and direction is reversed. Reversed means this will be S and this will be N. We will reverse the poles. So as you see, the line become closer because it will express the stronger magnetic field, and the right hand become south.